The speed of AI development right now, it feels like trying to drink from a fire hose, doesn't it?
It really does. Keeping up is one thing.
Yeah, but actually understanding what these systems can do, especially the tricky stuff like offensive cyber, that feels different. How do we really know? Are the usual tests telling us the whole story?
That's exactly the problem. And frankly, often the answer is no. Initial tests, well, they frequently give an incomplete picture. There's often a gap, right, between what an AI could potentially do and what we see in those first evaluations.
A gap.
Yeah. And figuring out how to bridge that gap, how to get the most out of the AI for a specific task, that's the challenge. And this deep dive, it's based on this really fascinating recent paper that tackled this head on.
Oh, interesting. So they didn't just talk about it.
Nope. They actually explored a pretty innovative way to get a better read on AI's offensive cyber skills. They threw them into the fire, basically, into real-world cybersecurity competitions capture the flag events, pitting AIs against human experts.
Okay, CTFs. So our mission today, diving into the sources you've shared, is to unpack this whole approach. We need to understand, like, why the standard evaluations fall short, how using these CTFs gives a better signal, what the results actually show to hear they were surprising, and, what this all means for judging AI risk. Let's jump in.
Sounds good.
So let's start with that problem you mentioned. Why is it so hard to know an AI's true capabilities right off the bat? What causes that disconnect?
Well, the paper talks about something they call the evils gap. Evils, short for evaluations.
It's evils gap. Okay.
It's this tendency, this pattern they see, where initial tests consistently underestimate what the AI model can actually achieve. And it's not usually because the model itself suddenly gets smarter overnight.
Right.
It's more about us, the humans, figuring out how to interact with it better, how to unlock its potential for that specific task we're testing.
Ah, so it's about how we use it. Is that the elicitation thing the paper mentions?
Exactly that. The sources define AI elicitation as, and I'm quoting loosely here, the art of extracting maximum task-specific performance from AIs.
The art of it. Okay.
Yeah, think of it like tuning a really complex instrument. You hand someone a Stradivarius, they might make noise. But getting a Yo-Yo Ma level performance, that takes understanding the nuances, the right bowing, the fingering.
Yeah.
That's the elicitation for the violin.
Okay, makes sense.
For AI, it's finding the best prompts, the clever ways to chain model calls together, maybe integrating the right external tools. It's the whole system, the agent harness you build around the core AI model. And figuring that out takes time. Takes experimentation. It's not obvious upfront.
Got it. So this evils gap can be pretty significant then.
Oh, absolutely. The sources give some really stark examples. They mention Meta's CyberSeval 2 benchmark. It's designed specifically for testing AI on cyber tasks. Initially, it showed pretty low success rates on some tough vulnerability types.
How low?
Like just 5% success for finding buffer overflows, and only 24% for advanced memory corruption problems.
5%. Wow. That sounds not very capable for those kinds of critical flaws.
Exactly. That's what you'd initially think. But then the sources point to work done by Google's Project Zero. They took the same underlying AI models.
The same ones.
And with what the paper calls straightforward agent modifications, basically, better elicitation, a better harness, they pushed those numbers way, way up.
How far up?
To 100% success on buffer overflow.
Not 100% from 5.
Yep. And 76% on advanced memory corruption, up from 24%. It's a completely different story about the AI's capability.
That's not just tweaking. That's a fundamental shift in understanding.
A massive shift. And there's another example from something called the Intercode CTF benchmark. Initial AI performance was pegged around 40% success.
Okay.
But later work, focusing purely on improving the elicitation, they got it up to 92% success on the same benchmark. And they did that in just 5 weeks of elicitation.
Wow. So just 5 weeks of figuring out how to ask the AI properly made it more than twice as effective on that benchmark.
Pretty much. It really shows how performance is tangled up with how good we are at using the tool.
Okay, that hammers home the point. So why is getting this right, closing this evils gap, so crucial? Especially, when we're talking about AI doing potentially harmful things like offensive cyber attacks.
Well, because if we want to make smart decisions about AI, informed governance and responsible deployment, as the paper puts it.
Right.
We need accurate information about what it can actually do, especially in these high-stakes areas. If our tests consistently lowball the AI's capabilities because we haven't figured out the best elicitation yet,
Then our risk assessments are based on bad data.
Exactly. We might think an AI is only capable of, say, 5% success on some dangerous task,
Yeah.
when someone who really knows how to elicit its performance could get it to 100%.
Yeah.
That changes the risk calculation entirely. We need evaluations that show us what the AI can really do when it's, quote, optimally elicited.
Okay, the problem's clear. One team testing in-house might miss the mark. So what's the big idea? What's the innovative solution this paper suggests to get a more reliable picture?
This is a really clever part, I think. Instead of just one internal team trying to figure out the best elicitation techniques, which takes time and might hit blind spots, they propose crowdsourcing it.
Crowdsourcing, like getting lots of people involved.
Exactly. The core idea is simple but powerful. You let different teams compete on getting maximum AI performance on a task. You harness the collective brainpower, the diverse approaches of a whole community.
Okay, that makes intuitive sense. What are the benefits they see?
Several big ones mentioned in the sources. First, you just dramatically increase the chances that someone somewhere will stumble upon or invent a really effective, maybe non-obvious elicitation technique. Different teams try different prompts, different agent setups.
It's like having hundreds of people trying to tune that violin at once, not just one expert.
Precisely.
Yeah.
It also makes the final evaluation more robust, right? It's
Yeah.
not dependent on the biases or limitations of a single team. If the top performance emerges from a competition with many diverse attempts, you can be more confident that you're seeing something closer to the AI's true potential with current human ingenuity.
Okay.
And a really neat side effect, especially using CTFs, is you get human performance data at the same time, on the same tasks.
Yeah.
So you can benchmark the AI directly against skilled humans at scale.
That's huge for context.
Yeah. And they even suggest a practical way to keep this going. Elicitation bounties.
Yeah.
Basically offering prize money to incentivize teams to find and show off the best AI elicitation methods quickly and efficiently.
Right, putting money on finding the best ways to use the AI. Okay, this is where it gets really practical and exciting, I think. They didn't just suggest this, they actually did it. Using these capture the flag competitions, can you remind us, for anyone less familiar, what exactly is a CTF in this world, and how do they use them for AI testing?
Sure. So a CTF, capture the flag, it's basically a cybersecurity game or contest. It's designed to test practical offensive skills. You have participants solving challenges, maybe cracking codes, finding flaws in websites, reverse engineering software.
Finding the hidden flags.
Yeah, exactly. Finding those hidden flags by exploiting vulnerabilities or solving puzzles and like simulated hacking playgrounds. The researchers saw these as perfect, ready-made environments. You have the infrastructure that challenges a community of skilled humans already competing. It's a great way to test offensive AI skills in a setting that feels more real than just a static list of problems.
Makes sense. And they ran AI tracks at two specific events. You mentioned AI versus humans and cyber apocalypse.
That's right. The first was AI versus humans, a smaller event they organized specifically for this research.
Yeah.
About 400 teams joined. It had 20 challenges, mainly focused on cryptography and reverse engineering. And crucially, these challenges were designed so you could solve them with local tools, analyzing files on your own machine. That made it a bit easier for the early AI agents to handle, no complex network interactions needed.
Gotcha. And the other one, cyber apocalypse.
That was different. It's a huge established annual CTF, like 8,000 registered teams from all over.
Wow, big difference in scale.
Huge. And the challenges were much more diverse. Critically, many of them required dynamic interaction, talking to remote servers, exploiting live web services, dealing with network protocols. This was key because it tested the AI agents on more complex, stateful tasks, not just static analysis. And that turned out to be a much tougher hurdle for some of the AIs.
All right, the moment of truth. How did the AI teams actually do when they were thrown into these competitions against humans? What was the payoff?
Well, the results were, and this is a direct quote from the paper, wildly exceeded initial expectations.
Wildly exceeded. Okay.
Yeah, especially in that first, smaller AI versus humans event with the local challenges. The paper says the AI agents significantly exceeded initial expectations and quickly saturated the challenges.
Saturated them, meaning they solved most of them.
Pretty much. The best performing AI team actually ranked in the top 5% overall. That includes all the teams, human and AI.
Top 5%. That's incredible.
It really is. And even if you only look at teams that solved at least one challenge, they were still in the top 13%. And maybe even more telling, Most of the AI teams actually outperformed most of the human teams in that specific event.
Most AIs beat most humans. Wow.
Yeah, 4 out of the 7 AI agents solved 19 out of the 20 challenges, nabbed some prize money too. The authors directly say this highlights the power of crowdsourcing. Different teams figured out how to make the AIs work really well, really fast.
That really gives you a solid quantitative measure of what's possible when the elicitation is good, at least for those types of tasks. What about the bigger event, cyber apocalypse, with the trickier, more interactive challenges?
Still very impressive, though different. In Cyber Apocalypse, the best AI agent achieved a top 10% overall rank.
Still top 10% out of 8,000 teams is nothing to sneeze at.
Absolutely not. That's top 21% if you only count teams solving at least one challenge. But the key difference here was that the AI didn't saturate the challenges.
Ah, okay.
So this event gave different data. It showed not just the peak performance, but also the current limits of the AI agent designs, especially when faced with those dynamic, interactive problems we talked about. It painted maybe a more nuanced picture of the cutting edge in a complex setting.
That makes sense. Now, what about speed? We often think of AI as being lightning fast. Did the AI agents just blow the humans away in terms of how quickly they solve things?
Interestingly, no, not necessarily. In the AI versus humans event, the study found the AI teams were actually on par with top multi-human teams speed-wise.
On par. How come?
The researchers asked the top human players about this. And the humans said their speed wasn't about raw thinking power, but came from extensive experience as professional CTF players. Years of practice, knowing the standard tricks, having optimized workflows. One player talked about being on internationally ranked teams for years. Deep human expertise, it seems, can still match AI speed, at least in these tasks that rely heavily on recognizing patterns and applying known techniques quickly.
That's fascinating. Human experience still holds its own there. Now, the paper also brought in a more academic concept to measure AI's ability on longer, more involved tasks. Something about a 50% task completion time horizon. What's that about?
Yeah, this is a metric borrowed from places like MBTR, who think a lot about AI evaluation. It's trying to give us a more tangible feel for AI performance compared to human effort, especially for tasks that aren't just quick wins. It basically measures the time humans typically take to complete a task that AI models can complete in 50% of cases. So if an AI can solve a certain type of problem half the time, how long would that same type of problem usually take a human?
Ah, I see. So it links the AI success rate to typical human effort. Why is that useful?
It helps us understand the scale of task complexity the AI can reliably handle. It moves beyond just can it solve it to how much sustained human effort is this AI performance equivalent to. Especially useful for tasks needing step-by-step reasoning or coherence over time.
Right. And what did they find using this metric with the CTF data?
Looking specifically at the cyber apocalypse data, where the challenges had very difficulty and weren't fully saturated by AI, the study estimated that AI agents could reliably solve cyber challenges that require approximately 1 hour of effort from a median CTF participant.
1 hour of median human effort. Okay, that feels like a really concrete benchmark.
It does, right? It gives you a specific anchor. It suggests that at the time of these tests, AIs were getting capable of handling structured technical problems that a reasonably skilled human competitor would spend about an hour on. And they note this lines up with other research suggesting modern AIs can tackle software engineering tasks needing about an hour of human expert time too.
That 1 hour number really sticks with you. It gives a sense of scale. And as we've established, getting any of this performance isn't just about the base AI model. It's hugely about that elicitation, the engineering around it, the agent harness. What were some of the specific, innovative design choices that made the difference for the winning AI teams? This seems like where the real practical innovation is.
Absolutely. This is often where the rubber meets the road in applying these powerful models. It's way beyond just writing a simple prompt. The sources give some great examples. One high-performing agent called CAI used a custom harness design they spent about 500 dev hours on.
500 hours just on the harness.
Yeah, that's a serious engineering effort focused purely on how the AI interacts with the CTF, processes the challenges, tries solutions, checks results.
Oh, great. Wow.
Then there was another top agent, Imperturbable, built by just one person who spent around 17 dev hours on agent design. Much less time, but still highly effective because of cleverness.
So what was the key there?
It relied heavily on iteratively tweaked prompts. The developer shared examples like designing prompts to stop the AI from just guessing flags based on how words look.
Avoiding simple pattern matching fails.
Exactly. Also, ensuring the AI actually read and understood the entire task instructions before jumping to solve it. and even prompting the AI to suggest using simpler standard tools available in the CTF environment when the big language models seem to be overcomplicating things or struggling.
So guiding its strategy, managing its weaknesses, steering it towards tools it could actually handle within the environment, that sounds like sophisticated coaching.
It really is. It's strategic guidance baked into the prompts and the surrounding code. And to show how vital this is, the paper contrasts these successful agents with Palisade's own more basic agents. They use things like just a standard prompt for Claude code or a generic React and Plan agent design.
And how did they do?
They performed poorly in cyber apocalypse. And the reason wasn't necessarily the underlying model. It was because their simpler harnesses weren't built to handle that interaction with the external machines needed for about 2/3 of the challenges there. They couldn't manage the networking, the back and forth with remote systems that the custom harnesses could.
That really highlights it. The innovation isn't just the model, it's the sophisticated engineering around the model tailored to the job.
Precisely. The elicitation embodied in that agent design is critical for unlocking performance on complex interactive tasks right now.
So, given these compelling results in this whole crowdsourced evaluation method, who really benefits from this approach? What could this mean for the future?
The sources lay out benefits for a few key groups. For policymakers, for R&D agencies, these CTFs are already happening, generating this rich source of evaluation data. The papers suggest that with relatively modest funding for AI tracks, prizes, coordination, you could build a sustainable system for getting timely and accurate situational awareness about AI capabilities in realistic settings.
So governments could tap into this existing ecosystem.
Yeah. And for the big AI labs building these models, these open competitions are a fast, low-cost way to find capabilities their own internal teams might have missed, overlooked elicitation techniques. Plus, it gives them an independent external benchmark to validate their internal tests against. Adds credibility or flags areas needing work.
Good for validation.
And for the CTF organizers themselves, adding AI tracks can boost their events' visibility, attract new kinds of participants, AI developers alongside the human hackers, and generate new research interest and media attention. Seems like a win-win-win.
A whole ecosystem. Was there anything unexpected that came up during this? Maybe something about the human element in all this?
There was one quite interesting finding, actually. It was about recruiting offensive AI startups to participate.
Offensive AI startups, companies building AI for hacking.
Basically, yeah. The researchers invited 9 of them, figuring they'd be keen to show off their tech in this competitive setting.
Makes sense.
And,
None of them participated. Most didn't even reply.
that is unexpected. If your business is offensive AI, why wouldn't you want to prove it works in a CTF?
Right. The authors had a couple of theories based on follow-up chats. One idea is maybe these startups have specific private clients and don't feel the need for public leaderboard validation. Or maybe they rely on, quote, alternative forms of credibility, like doing well in bug bounty programs, finding real bugs for cash, which is a different kind of competition than CTFs.
Interesting. So maybe CTFs aren't the right validation venue for everyone in that space.
Perhaps. Though it's worth noting, some individuals and one smaller offensive AI startup did reach out independently later and joined in, so there is some interest, just maybe not from the established players they initially targeted. Okay, so let's try and wrap this up. To sum up this whole deep dive.
I think the main takeaway is that this crowdsourced elicitation, especially using competitive settings like CTFs, looks like a really promising approach. It tackles that evils gap head-on by using collective intelligence to find out what AI can really do, giving much more robust, much higher fidelity results than we might get otherwise.
And those results, well, they wildly exceeded initial expectations, as the paper put it. Seeing AIs hit top 5%, or most AIs beating most humans in that one event. It gives a much clearer and frankly more potent picture of current offensive AI capabilities than maybe some earlier tests suggested.
Exactly. And benchmarking against humans in these skill-based competitions provides a signal that's more interpretable and policy relevant. Knowing the best AI could reliably do tasks needing about an hour of median human CTF effort that gives a concrete, understandable measure of capability on non-trivial cyber tasks.
This whole exploration of using crowdsourced competitions to really measure AI definitely leaves you with a lot to think about. We've seen that an AI's true power might stay hidden until someone figures out the right art of elicitation, and throwing them into the competitive mix with humans, like in CTFs, seems like a powerful way to unlock and benchmark that potential.
And think about that specific finding again. AI reliably solving problems that take a median human competitor about an hour. Just pause on that. What kinds of practical, skilled work can a reasonably talented person accomplish in an hour? What does that benchmark signal about the types of tasks AI is verging on being able to handle? Maybe sooner than we thought. And given how fast both the models and the elicitation techniques are improving, how quickly might that 1 hour benchmark shift upwards?
That's definitely something to keep mulling over as we watch this space evolve and as we all try to figure out how to measure these incredibly powerful tools effectively and responsibly. We hope you got some valuable insights from this deep dive into AI cyber capabilities and the innovative world of crowdsourced evaluation.